So I saw a talk by Russell Davis once, and he said every presentation should start with this video, and I actually agree. So, hi, my name is Dirk Songuer. As my wonderful introduction said, I don't need to do anything. This is pretty much where I work. I work in the Microsoft Mixed Reality Studios. And as said, this is pretty much what we do. We try to support partners and our customers with just trying to understand what mixed reality is, what they can do, what they can work on, what makes sense now, what makes sense in kind of 3 to 5 years into the future. And this is my desk. Actually, yes, I try to keep it more clean and more tidy, but this is pretty much how it usually looks. And this is pretty much the first thing that people notice. I mean, this is pretty much what they expect when they hear I work in the mixed reality studios. It's actually not the only headset I have. If the picture would go more to the right, you would see like Odyssey, HMDs, VR headsets, and other stuff. And it's pretty much what we have lying around in the desk, just like in our work desks. And this is interesting. All these headsets are interesting to talk about. This entire spectrum of mixed reality going from augmented reality, where you can see through, actually starting with real reality and then augmenting that all through these kind of weird things to virtual reality. That's just interesting to talk about. It's interesting to have to talk about those little differences in terms of you start with real reality where you have your things that you see around you, your desk, your other people, your colleagues, your furniture, and then you start to augment things, you start to replace things. You take the desk and make it virtual. You start adding things like little gadgets, little widgets, little things that actually exist. And then you start replacing people and replacing them with avatars, being able to do holoportation and work together, although you're remote. And then you end up in a place where essentially everything is virtual, which is virtual reality. Yes, it's really cool to talk about those differences, and yes, what is the difference between an Oculus and a Vive, and what is the difference between a Vive and a Vive Pro, and so much is happening, and all that is super interesting, especially when you talk about these weird little things like augmented virtuality. How about we take a virtual reality headset where we can't see through, we add cameras, and then we have every pixel under our control, or like simulated reality. All those weird things, and this is amazing, and not what I'm going to talk about today. Because essentially, when we talk about mixed reality, what we're really talking about is this: injecting purely digital elements seamlessly, so in a way where we don't notice anymore, into an enhanced physical world. An enhanced physical world meaning a world where we actually have digital abilities and capabilities in everything around us. So when we see examples like these with mixed reality, which we usually do when you talk about mixed reality, everybody brings up this slide. Personally, I like Harry Potter better, because it's this kind of, you have a totem and you can do magic things, and then you see things that don't necessarily exist, and these have consequences, and this is really cool. But what I really, really, really love even more is science fiction from the 50s and 70s, specifically illustrations. Because look at it, it's mad. Like, I don't know what this woman does. She has wings, and what is this egg? I don't know what this egg is. Maybe it's keeping her flying, maybe it's just a form of GPS and she's navigating home, or maybe she's just opening her garage door with it. I don't know. But it's cool. It kind of captures your imagination beyond a screen in the air. This kind of notion of manipulating screens in the air is cute, but that will only be a part of the overall magic that mixed reality will bring. Really, it's about this woven technology. So let's talk about those things instead of headsets for a moment. Let's make a couple of assumptions. And usually, I talk about these for an hour or so, so I'm going to condense this, so please follow me and believe me for a second that this actually makes sense. So the reason why the Internet of Things actually exists is because to add digital abilities and capabilities to the world around us. And really, like, in any way, shape, or form. And the reason we do this is because it's actually cheaper than not doing it. And as developers, we maybe can relate to that. If you think, how would you actually create a printer today? Like, from scratch, do a printer. What you would not do is go around, create purpose hardware, create custom kind of logic for it, create your custom SDKs. No, you take a couple of smartphone components, stuck them in there, use the smartphone capabilities and APIs, and just run with it. Because a smartphone can scan things, it can photograph things, it can very well print things. And this is why the cheapest printers you find online actually have all those capabilities. They have color touchscreen. They can fax. They have Wi-Fi enabled capabilities. They have Bluetooth capabilities. Because you get all that for free if you take smartphone components instead of developing your own stuff. So taking super smart components and making everything more and more digital is actually cheaper than not doing it. But this comes as a price. If devices become more and more complex, if you can do more and more things with them, well, it's nice that you can do something more with a switch, but then again, what's the additional interface? If technically your switch can serve the internet, your light switch, how do you interact with that? And that's pretty much where things come in that Michael just talked about. Cognitive services will support these things. It will allow them to interact with people in a more natural way. So, in a way, cognitive services that Michael just talked about are there to make smart things even smarter, so we can talk to them. So these digital layers help us control digital physical objects and their behaviors. So super relevant what you just saw in the talk before. But these digital things are not really mine. They're not really in my context. Context matters. Like, it is very important if I stand in a room, it's my Spotify, it's my playlist, it's me that is using it and is my music and playlists that I want out of my speaker, not necessarily all the other devices that are able to kind of relay sound. And for that, you have computational graphs. These concepts are there to essentially give context how things, people, and places relate to each other. And that's super interesting because essentially a graph makes the Internet of Things into the Internet of your things. It is aware what you are, who you are, what you're doing in this specific moment, what your upcoming meetings is. So if you go, for an example, if you live in this world, 10 years in the future, and you get up and your bed already knows that you didn't sleep well, and your toothbrush analyzes that you're kind of slightly sick, and then already your car knows that your next meetings are kind of hard, and it's about your rewards or your appraisal meeting, and then your car reacts by making the seat just so, putting on some nice music, and it does this specifically for you. But then again, that doesn't really work, because as every experience would be catering to my individual needs, how would that really work? How would I be able to really understand a world where all this happens in the background magically? Do I really trust this world that it works for me? And the answer is probably not. But mixed reality as a concept is a window immersing ourselves in this super complex, hyper-contextualized, connected world in an intuitive way. So if you think about this world, if you think about the Tony Stark, the Harry Potter image, is actually this what we're talking about from a technology point of view. You have your physical reality, it's the physical thing. You have your digital kind of ghost dimensions of the thing. These might be states. What is it doing right now? What is the temperature of the thing? What is the state of the thing? Is the thing on or off? Is it who is using the thing? Who is near the thing? Who is close to the thing? And then we need some kind of system that brings everything together. And then we can add another layer where you have shared experience or personal experience with them. So essentially this. I don't know what the egg does, but it kind of works because of that. So when I think about mixed reality, or when we think about mixed reality in the studios, we really think about these kind of things. We think about multi-device, because at the end of the day, it doesn't matter what device you are. You might have goggles, you might have a VR headset, you might have an AR headset, you might have some weird little headset that beams something into your head. You might have a tactile thing that taps slightly on your head because you're vision impaired. It doesn't matter. And you have artificial intelligence and all that machine learning and cognitive services, and you have serverless stuff that just happens. And that is powered by an intelligent cloud and running on intelligent edge, which is essentially running on the devices around you. So here's an example of what we actually did with ThyssenKrupp together in terms of the mixed reality studios. Maybe?
At ThyssenKrupp Aerospace, we partner with the world's leading aerospace companies to simplify their supply chain management. We have a complex flow of materials in our factory to keep production running smoothly.
Our top priority is keeping people safe and making sure they have access to all the tools and information they need to make better decisions quickly.
Microsoft's mixed reality tools are helping us get there. As we take on new projects, we need to optimize our workflows. With Microsoft Layout, we're able to make design changes in our actual factory space with 3D holograms.
Once we have an optimized workflow, we use spatial analytics to help drive quality improvements. We're running 24/7 on most saws, so it's expensive to take one offline. Spatial analytics listens to our machines and helps to tell us the right time to replace a saw blade, balancing quality with the bottom line. One of the most stressful things in our business is when a customer calls to tell us they have a grounded plane waiting for a part. We have to drop everything and get that part out so the plane can get flying again. We need to move fast since it affects all of the other orders in our pipeline.
Cortana, what 14-foot saws are available?
Cell 14D is available.
Cortana, tell planning that I'm moving to Cell 14D.
Integration with Teams and Cortana allows our workers to make quick, in-context decisions that speed up production. No matter how fast we're moving, we need to deliver the highest quality products every single time. When we finish an order, it's important to document the condition it was shipped in.
Spatial analytics helps us with the quality assurance process. We can store time-stamped information and photos about our work orders for future reference. With Microsoft's mixed reality tools, we're able to work faster, safer, and at a higher quality than ever before. We can't wait to scale this across our entire organization. There's so much possibility.
So, if we go back to my desk, this stuff is every bit as important as the headset. The kind of inconspicuous hardware lying all around, littered around our studio, plus me having Visual Studio open on probably my laptop screen, but the upper screen is probably something like Azure or some other machine learning stuff. You've heard Michael talk about all the other contenders. There's Amazon, there's Google, there's IBM, obviously. So all of these are creating these things, creating these infrastructures to actually create this mixed reality world, this mixed reality infrastructure that go beyond the headset. So let's talk about them, because you can actually work on all this right now. So let's do a little project. And I wanted to do this live, but the kind of waiting times to get these stuff set up is kind of long. So step one, just grab a couple of physical objects. And these are IoT enabled. And obviously, we have this for a very long time, all these kind of Raspberry Pis, these Arduinos. You have specific vendor stuff like Qualcomm boards, Intel boards. You have Particle, which is doing really, really cool stuff with connected things. And these are cool. These are amazing. These are there for decades, literally. And they're super cheap. So grab them. And what we also really like is a system called Groove. So previously, a while ago, you had to use breadboards, and then you have to do cables and other things. Groove is actually an absurdly easy prototyping system. It's actually going beyond that. You can very well do small-scale work with that. And the point is, are these connectors, and they're literally standardized connectors. So you use these connectors for everything, and you get the sensors, pretty much every sensor you can imagine, in those little packs. So you pretty much create your list. I want to do this, I want to do that. So this is a board I'm going to order. These are the sensors I'm going to order. You can literally build to order. It's pretty cool. And then you just plug them together. It's as easy as that, and you run that. And also the systems and the frameworks running on these are super mature. So yes, you can use Windows IoT Core, but you can also use Linux. You can use frameworks like processing. You have a wide range, a wide array of things that you can use. If you're a JavaScript developer with Node, that's perfect. If you want to use C++, cool. So there's literally an endless opportunity there. Step 2, well, create your abilities of the physical objects. Start coding. Start your processing stuff, start your C++ stuff. And this is pretty much just opening your Visual Studio and just literally going, hey, I'm creating a light sensor, I'm adding a sound sensor, and a temperature and humidity sensor. Cool. So I'm going to ask them every timer amount of milliseconds for their data. And that's actually pretty easy. And then you connect the physical things to the cloud. And this is where all the systems come in that Michael just talked about. And yes, you can get this from pretty much, again, Microsoft Azure or IBM or Amazon. For Microsoft, it looks a little bit like this, and it's literally like 5 clicks to create an IoT hub. And the purpose of the IoT hub really is, at this stage, to get you up to speed with one of the hardest issues in the space, which literally is just security between devices and your cloud or your data center. Because you see a lot of these articles in terms of, hey, this IoT thing was hacked, people can watch my baby monitor, people can hack inside my smart door, all these kind of things. So security is a big concern, and literally IoT Hub and the other solutions get rid of that. You just install it, you add a provisioning. So you provision your device, you say, hey, this is a new device, I provisioned this against my cloud, and then it's known to the cloud, and as soon as you exchange the key, which is usually stored in some kind of TPM chip on the device. If you don't have that, you can do it in software simulation, but just don't for productive use. And after that, you're able to create what is usually known as a digital twin. And a digital twin essentially just says, this is what this device is doing right now. What is the state? We talked about these states before. Is the device on? Is it off? Is the light green, red? What is the color of the light? What is the temperature of the light? What is the input of the sensors? Cool. So that was about like an hour real time by that point. Next step, transfer the data. You literally do an HTTP send or something. You ask, what actually happens if you use these kind of platforms is, you ask, hey, provisioned device, get a secure connection to the hub, and then send some data. And that's literally usually it. And the next step, you add some rules around that. What happens if this happens? What happens if that happens? And you can essentially decide where you want your telemetry data, or where you want to kind of manage your telemetry data. Do you want to do stuff on the device? For example, are you actually working with data that is coming in 40,000 times a second? You probably don't want to transfer that to the cloud, so you can do some pre-calculation on the device and maybe just send other kinds of telemetry data. It really depends what you want to do, but essentially you can just use compute functions for that. This is where the serverless stuff comes in, where you just say, okay, I send you something, cloud, do something with it. And depending on your use case, this might be, well, hundreds of thousands of devices doing this every second, or it might be a couple of devices doing this once an hour, or it might actually be a mixture between both, depending on the time, depending on the date, depending on the situation the device is currently in. So serverless makes sense. Instead of having the full compute capabilities there all the time, you just spin it up whenever you want to. And then you just connect a couple of applications to your roles. This is literally, hey, graph, do this. If it gets too dark, like here, send me a message in Teams. And again, this is literally doable where most of this stuff has finished recipes, much like if this, then that. So then the question, once I explain this, usually the first question is, well, how is this mixed reality? And if I'm talking to Unity developers or headset developers, usually it's like, where's my headset? Where's my engine at? Well, if you actually looked at the use case at the video before, you saw something like this. The small kind of device little thingy. And in an enterprise use case, in an enterprise world, in this kind of like controlled environment of a factory, that kind of makes sense because you can explain to your workers what it actually is. You can train them what it actually means if it's blue, if it's green, if it's red, and you can also teach them what happens if you tap on it. But I mean, come on. It's mixed reality. We have a headset. So once you've done all this homework and once this data infrastructure is actually there, use your headset to actually show the information. Show what the sensors are currently doing, what the device is actually attached to. Show the status, what it does, and actually show what happens when you do a single press, when you do a double test, and if you do a long press. So all this additional information is interesting. And also, if you think about the graph and additional capabilities, you can use your headset, since most of the headset actually have inside-out tracking, so they understand what's around you. You can even use that to integrate objects that are not inherently smart and also pull them into the graph. Something like this.
Remind me to water the plants.
So yeah, these are, I wouldn't necessarily call them stupid little experiments, but interesting little experiments that might start off with a stupid idea. In the sense that if you look at something and the plant is not inherently smart, it cannot be, but your device knows where you are, it knows who you are, and it roughly knows what's around you and what you're looking at. So it can make the thing that you recognize smart just by adding it to the graph. So back to our little experiment. Okay, we have a couple of sensors. What do we do with it? Well, we can do stuff like this. This is a cute little experiment from Nikolai Lam, where he uses this kind of data. He actually ran around and scanned the Wi-Fi signal strength in an area. And what he does is, you can now put on your headset and literally see Wi-Fi reception. You can see parts of the electromagnetic spectrum that you're not able to do otherwise. Without temperature sensors, we can literally see temperature. And since we have the historic data, we can scroll back in time. Show me what the temperature looked like yesterday. And since I have machine learning models, I can literally predict, show me what the temperature will be tomorrow, based on the machine learning models and maybe additional input from the weather report. And now think of the actual factory. What he did, show me how this workstation looked yesterday. And by the way, do I have additional capacity to manage this additional contract? Show me how this workstation will look next week. Will I actually have capacity? We will be able, with these systems, to use our headset to essentially transcend through time, look through time, and see things that we are usually not able to see otherwise. So going back to this, it is a window into the digital dimensions that are otherwise not be able to be seen. All the sensor data around us. Mixed reality literally is there to allow an immersive, intuitive window into this. So when we talk about mixed reality, ability and connections of devices visible to help users navigate these digitally enhanced environments, to actually understand what is going on, to be able to literally make sense of them and utilize them. So I might not know what this egg is, but I would really, really like to find out. And the thing is, I get asked a lot, what is the killer app for mixed reality? And the answer is, you're doing it wrong. If you talk specifically about augmented reality and what goes there, the killer app is the environment. The whole purpose of this is that you can see your environment. If you think about a single app that will be the killer app, it's not. You can do that with everything else. The whole purpose of this is the environment around you. And with that, thank you. And by the way, we're hiring. Otherwise, yes, thank you.